Good morning, everyone. Welcome to another episode of Xao Talk Show. So today we are going to do geometric inversion, Wolfram language coding, and lots of fun stuff. Okay, basically centered around the mathematics, geometric inversion. You are looking at some of the fantastic images of geometric inversion, and I'm going to do some live coding and teach you Wolfram language. How do you do that? And Wolfram language is free, by the way, so you can download it. Just search for Wolfram language free. I'm gonna show you my links, okay? And also, so you are looking at some of the images, fantastic, beautiful images of geometric inversion, okay? The concept of geometric inversion, and also working in 3D. So. And also, okay, so today, and you are also looking at my keyboard. So I got a new camera. So let me show you the new camera. Okay, so so I bought a new camera because the Logitech. So now I have two. You can see my keyboard. I'm gonna work on it, and you can see how I operate, the most efficient way to operate with emacs, soft-like keys, and keyboard markers, with the Ultimate Hacking Keyboard and Kinesis Advantage 2 keyboard. Red switches. Okay, you want linear light switches if you already have repetitive strain injury hand pain. Okay, and today is 2021 October 1st. Okay, so anyway, so I bought a new camera because, so right now I'm using this one, Logitech C920. Okay, something like $70. Then I bought a cheap, China cheapo. Okay, this one, fantastic, only $40. And so the China cheapo you are seeing is this one. Well, it's pointing at my keyboard. And so I have a review here, so you can see I explain the what's good or what's bad. Okay, so I would recommend the China cheapo, $30 cheaper than Logitech. Okay, so just go to my XRD keyboard blog and search for this your Logitech C920 versus cheap webcam. You'll find my review. Okay, so that's about webcam I bought, and that's about the keyboard. And shall we start to do geometric inversion? Okay, so let's see what topic. So let's look at my notes. Show graphics. So I showed you some images of geometric inversion, web camera, and okay, so let's begin to talk about what is geometric inversion. Okay, so if you have questions, comments, post it. Okay, I love to see your comments and questions. Hi guys, hi people of the world. Okay, so geometric inversion, it's pretty simple concept. Okay, so we are getting into math now. So you can see, so listen carefully. Okay, geometric inversion basically is a function. Okay, it's a function that takes in a vector or point in the plane or in three-dimensional. It works in any dimension. Okay, so geometric inversion is a function. Okay, it's a function. The argument is a vector. Okay, two-dimensional vector, three-dimensional, four-dimensional, whatever. It's basically a sequence of real numbers. Okay, that's an input, that's an argument to the function, a point. Okay, let's just talk about in the two-dimensional case. So a vector, 2D vector. Okay, the output is another 2D vector. So essentially, it's a function that takes a vector and output a vector. Okay, oops. So this let's see, my keyboard shaking. So a function. Okay, so now let me show you. So how is this function defined? Let me explain. Okay, so given a function, given a point P, remember it's a function that returns a new point, a new vector. Okay, so given a point P, it returns another Q. But how is it defined? Well, it's defined this way. Okay, you draw a line from the origin, from the center of the coordinate to the point P. So you have a distance from O to P. O is the origin, so O to P is a distance. So the Q is another vector that lies on the same line from O to P. But the distance of OQ times the distance of OP is equals to the radius of inversion, basically 1. Okay, okay, let me explain. So to define inversion, you need a circle. Okay, let's say the circle at origin of radius r. Okay, so given a point P, you want to find it returns a point Q such that Q lies on the same line from OP. Okay, the OP ray. Q lies on the same line as OP. But however, then where is Q then? Where is Q? Well, Q is such that the distance of O times P, the distance of OP times the distance of OQ equals to the radius of the circle. Okay, that's you can go to Wikipedia, just look for geometric inversion. You'll find. Actually, go to my website. Okay, so go to Visual Dictionary of Special Plane Curves. So that's my website. That's my most popular website, linked by thousands of universities, math departments, starting from late 1990s. So you go to Visual Dictionary of Special Plane Curves. Then you just go to inversion. Okay, so there's an inversion, involute, envelope, evolute, roulette, geometric inversion. Okay, it's called, by the way, it's called geometric inversion, not just inversion, because inversion means quite a lot of things. But essentially, the geometric inversion. Okay, we already gave you the definition, so you can read the details here. And I also want to tell you, so we gave you the definition of the geometric inversion. So, but what is the essence? What does it? I mean, why do you need this function? Essentially, this geometric inversion kind of defines multiplication. So you could say, in a way, it defines multiplication. Another way to characterize it is that it's a function that swaps. Let me see if I have a good picture somewhere here. Okay, so let's see. It's a function that swaps any point outside of a circle to inside of the circle. Okay, so let me see if I have a good image to illustrate that. Beautiful, geometric inversion is beautiful theorem. I mean beautiful, a very beautiful process. Okay. And it's related to complex functions. Okay, so we are getting a bit digression. It's related to complex functions. So let me show you. Let's see where. So you have geometric inversion. Now where's a gallery of geometric inversions? Okay, so where's my galleries? Okay, so anyway, so somewhere linked, you can find. So here you are looking at all the geometric inversions. So for example, this picture is a geometric inversion of 7 circles, nested inversion. Okay, so you begin with 1, 2, 3, 4, 5, 6, 7 circles. Then you invert each circle with respect to each of the circles, and you do that two or three times, nesting. Okay, so you got this picture, beautiful. And this image, for example, you begin with a bunch of circles arranged like that, configuration like that, and you invert them with respect to each of the circle, then you got that. So now let me get back. So now I hope you will understand fully after watching this video what geometric inversion means. Okay, so let me emphasize a few things. Geometric inversion is a function. Given a point in a plane or in 3D space or in n-dimensional space, given a point, it will return a new point. Okay, that's it. It's just a function that takes a vector, returns a vector. And now, so what we mean, so when you see these, how does that work? So because each point, okay, so here is, this fancy graphics is more complicated. Okay, so let me perhaps we should focus on, just remember it's a vector, it's a function that takes a vector, returns a vector, and it's defined based on a circle of radius 1. Okay, so what it does essentially is that it swaps any point outside of the circle to the inside of the circle, and any point inside of the circle goes outside of the circle. Okay, and points on the circle of radius 1 remains on the circle, they don't change. Okay, so those are fixed point in mathematical jargon. So that's how you do geometric inversion. I mean, that's a function of a point returning a point. So what? But how do you get the graphics like that? Okay, so let me explain in basic detail. I mean, for those of you who are not too familiar with math. Okay, so here what you are looking at. Okay, let's go back. Okay, so let's go look at this image. Okay, so here you are seeing a grid. Okay, and after applying the geometric inversion function, it becomes that. Okay, so how does that work? Well, you see, a grid is a lot of points. It's made of lines, and so you consider each point on the line. Okay, for example, the corner point over here. So you apply the function geometric inversion to that point, and you get a new point. Okay, for that point in the corner, and you do the same thing for every point in the line, for every point on the grid. Then you get this. Okay, so that's geometric inversion of a 2D grid that looks like that. Does that make sense? Do I make sense? I hope you understand. Okay, so, and I hope I'm not being repetitous. Okay, so in this case, so here we apply geometric inversion to a grid, lines of grid. Now in this case, we apply a geometric inversion to a bunch of squares. Oh, by the way, let me also mention, when we apply the geometric inversion here, we actually do not apply to every point on the line. Rather, we just apply to the grid points. So like we apply here, 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 and same thing, here, 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 the grid points. So once we do that, we connect the points like how they are connected before. Then we got that. Now if you apply the geometric inversion to entire points on the line, what you get is a bunch of circles, because by a theorem, geometric inversion, any straight line becomes circles. Any circle becomes a line or circles. Okay, that's a theorem. That's one of the theorem in geometric inversion. So on this page, you can see the full explanation, and I hope you go there and study it. So we are, learning mathematics. So, okay, so now I want to demonstrate some Wolfram language code. Okay, so we explain how this image, what this image is. So in this case, we have a bunch of squares laid out on a grid, and we apply the geometric inversion to each corner, the vertices of the squares. Then what you get is this beautiful, this fascinating, this decorative mathematical patterns. So okay, so here we do the same. Now they look, there's kind of a visual impact how they are different, because this one you start with a square in the middle, then you get that, and this one you don't have a square in the middle and you get that. They are exactly the same thing, geometric inversion, but the outcome, the visual impact is slightly different. Okay, am I good? Let's see, video check, audio check. So let's remove that, and okay, so let's continue. So next, I want to show you. So here is a geometric inversion of a square grid. Then here, this is spectacular. Now this is a geometric inversion, same thing like that, except instead of squares, you have n-gons, regular polygons. You have hexagon, you can be triangle, hexagon, heptagon, 7-sided regular polyhedron, or octagon, or and so on, and pentagon, and 9-sided. So okay, I'm gonna show you. So here's a code. This is a Wolfram language code. Then here is a spectacular. You do the same thing like the first one, like this one, but now you make it into 3D. So you have a kind of a tiled, like pavement, like nice garden pavement pattern. And here and you see, so geometric inversion. Remember, it's based on a circle. Any point outside of the circle becomes inside, and inside goes to outside. So that means when you have a plane, you have lots of points outside of the circle. They become congested in the middle. You see, they all have this pattern. They become infinitely small in the middle. So, but that doesn't work well if you want a tiles, garden pavement tiles. So is there some way to make them to have this beautiful pattern, but without the congestion in the middle? Well, yeah, we can do that. I tried to do that. So this here is a result. So what you do is you start the grid. Remember we start with the rectangular grid. Now you move the grid points further apart, by using geometric inversion again. And also the size of each square will also be different depending on how far they are from the origin. So basically you begin with this pattern, not just the rectangular grid, but you begin with this pattern. Then after applying geometric inversion, you get this one. So now we have a tiled version. Okay, and there's also a 3D case we did like a month ago. So here's a 3-dimensional case of geometric inversion. Fantastic, beautiful. Now let's do some Wolfram language coding. Okay, so let me show you. Comments, guys, comments. Okay, so let's do some Wolfram language coding. Okay, so we explain geometric inversion, and so copy the code. Go to Wolfram language, select all, paste it, evaluate, so you can see. So there it is. Okay, so let's show some other, some more. Copy it, go to Wolfram language code, select all, paste, actually undo. Let's do a new one at the bottom. Do it. Okay, you can see. Then you can also magnify it. Okay. So let's do, so now this one is interesting. So because there are so many variations, this is a regular polyhedron. So let's do some experiment on that. And I'm going to explain the code. Okay, I'm going to explain the code. So you see, so let me show you the let's make them rendered as as mathematics. So this is Wolfram code. You can it's fantastic. Wolfram language is mathematical feature. So you can have this kind of typeset mathematics on the fly as you type. So no more the typical industrial programmers including these coders, Python, they want to argue and idioms and coding styles about when to press the tab. When should you have a tab, and whether should be space or tab, or whether how you code formatting, idiocy. Here you are seeing automated formatting on the fly. You see, for example, let me tell you, for example, this line, it's a long line, but if your window is small, it automatically become, it doesn't fly off the window, like typical programmers, they, like in emacs field region, idiocy. You see, so you are looking at the automatic, formatting. Okay, on the fly. And not just that, also mathematical typesetting. Okay, so anyway, that's a bit digression. So you are looking at, so let's modify the code. Okay, so let's see the polygon. So let's change the polygon to polygon number of sides. Okay, so actually you cannot see that. So let me change that. Polygon number of side 4. Okay. Evaluate it. So you got that. Okay. Okay, so now let's try polygon number. Let's magnify this so that and let's make it smaller. And let's remove this image. Okay, so let's remove. So let's do that. Okay, let me show you. Do that. Okay, so let's also remove that one. Okay, so we can see the graph directly below. So now let's magnify a bit. Okay, now let's change the polygon radius. Okay, polygon radius. Polygon radius 0.5, so that they don't overlap. So you see, now we got little squares, they don't overlap. Now let's polygon number of sides, let's make it 5, pentagon. So you see pentagon. Now let's say make it 6, hexagon. Okay, now the side, let's make the side larger so it's more interesting. So 3. Okay, let's see. So they overlap. Okay, so it's not, this one is not so aesthetic. Okay, so so anyway, so you see this one you begin with this pattern, and after you apply geometric inversion you get that. Okay, so let's see, how long have I been talking? Let's see, maybe I should move on to 10. Okay, we already talked for 30 minutes. Okay, so let's do the tiled version one. Okay, so copy it, make it smaller, go here and paste it. Okay, so here you got it. Okay, so then you can rotate the thing. Okay, so now this one. Okay, now this one is fascinating. So but let's use this code so it's fancy. So let me show you this code. Okay, let me show you in let me also mention XR wolfram, XR emacs wolfram mod. Okay, let's see. Let me show you. So yeah, let's start to do some typing. So 3D tile. Okay, so here is my XR HTML mod, magnify. Okay, so you can see here's an image of that. This section corresponds to this you see on the right. So here is the code. Okay, this section corresponds to the wolfram code here. So, but let's make it, let's do a backup and let's put it out onto a new buffer. So here's the Wolfram language code, and you can see it's using XR Wolfram mod. So let me show you. Okay, describe key, then press the key to go to XR Wolfram mod documentation. So you are looking at the documentation of XR Wolfram mod. Okay, so actually let me turn on this. Okay, so you can see. So let's go to the source code. So here's the source code. I just wrote this about 2 months, beginning 2 months ago. So it's fantastic. So if you are a Wolfram language coder, so there's lots of here are the built-in functions of Wolfram language, lots of code. So if you are a Wolfram language user and also a emacs user, you might try my code and buy it. Okay, so just go to PayPal, send me money and buy it. Okay, so let me show you. Wolfram mod. Okay, so here, so that's the emac list. So but let me show you how this works. Okay, so here is the code. This is how the code looks like. So what we want to do, copy the code. So one of the interesting things you can see is that how the code looks like in a typical like Emacs editor, and how it looks like. For example, let's copy. Okay, copy and paste it here. Okay, so and then let's make it typeset. Okay, so you can see it's much easier. It's much more readable when you have two-dimensional typeset code. Okay, now evaluate it so you can see. So here we got what we want, and magnify, and again you can rotate it. So you can see here is how Wolfram language renders the code, and also you can see syntax coloring. Very interesting choice. There are so many schemes for syntax coloring. The question is how do you color programming language code? For example, in Emacs Wolfram mod, I'm coloring all the built-in function names blue. Okay, so that's how I do it. But in Wolfram language, they color essentially they color just the local variables, and this is fantastic. This is actually, I believe this is the most useful. Color the local variables. Okay, but this is not easy to do in for example in Emacs, because you need syntax analysis. You cannot just do it by text processing methods or regular expression. You actually need to know the grammar of the, not just grammar, not just a syntactical grammar. You need to know the semantics of the language. You need a parser for the language. Not just the parser. You need you need to know the semantics of the language in order to color just the variable names. Okay, so that's how Wolfram language does it. They color the variable names. I believe that's the most useful. So, but also you can see how much readable, is when you have this, rendered in 2D typeset. So anyway, so but however, the flaw with the Mathematica notebook is that it's hard to edit, because let me show you. Okay, so for example, I want to comment out something. Okay, so let's comment out. Let's comment out this one. Okay, so comment out that one, copy it. Okay, paste it, evaluate. So you see, we don't see that. So in order to comment out, all I have to do is press a key. You look at the pink window, you'll see the command name and the key I pressed. You see, I just press the key, semicolon, and it calls comment dream. Do what I mean, and it comment out this code. You see, I can do it again. Do it again, do it again. So if I want to comment out a whole bunch of lines, I can just press that. Okay. But in Wolfram language, it's 3 plus 4 to comment. It's not as easy. I don't remember what's the key to comment. But anyway, you'll find I believe there's a key to comment out code, but then you have to select the code first. Okay, so let's look for it. Uncommon selection. Yeah, you see. So you do that, it just comment the current word. So you have to select the expression first, then / is uncommon selection. Okay. By the way, / that's based on, wait, Am I mistaken? Never mind. Okay. Yeah, so to edit code in Wolfram language is that's a flow, I would say. So I much prefer working in Emacs. That's why I created the Wolfram language mod. Okay, so what do I want to do next? So we showed that. So so let's see. So the 3D case we don't want to. So okay, what's next? Comments? No comments. Okay, what's next? Let's do some live coding of some new things with geometric inversion. Okay, can we do that? Yeah. So basically, I think we are done today. We talked for 36 minutes. I think we are done. Probably, maybe we can do some live coding of Wolfram language, or let me think. Okay, what we want to do. Beautiful, thank you. Aspen Century. Okay, so what's next? What do you think, Aspen? Should we do some live coding of Wolfram language, or any, or do I make sense about geometric inversion? Let's see what else we're gonna do. Okay, so if you like if you like Wolfram language, they sponsor me. They gave me a free copy of Wolfram language. So because I've been coding Wolfram language for 10 years in 1990s. It's basically the first language I mastered thoroughly. I coded every day for several hours a day for over 10 years. And I did several videos on Wolfram language before. You should watch. Just go to Xali Wolfram language, search for it. Yeah. So if you like to use it, of course, it costs you $2,000 if you want the certified version. If you are a employee at NASA, or if you are a Google corporation, it costs you $10,000, $2,000 something, $3,000. But if you are a student, it's like $250 something. Or you can get it free if you buy a Raspberry Pi. $70, you get it free. It's bundled. Or you can download free Wolfram engine or Wolfram script. It's free for personal use. So I highly recommend it. It's the most advanced language by far. It's a magnitude beyond. I talked about for an hour about why I think so. And you have seen some of the features that you will not see anywhere else. For example, I want to typeset this code. Okay, I press a button. You got these two-dimensional fractions and also square root. You see. Now in tech, typically the Unix people, the Unix people tech, it's silly, super silly. Okay, so I think I'm done for today. Do I have any Kinesis keyboard? Okay, the question is about keyboard. Any new developments in the keyboard space? Yeah, okay. Maybe I'm hoping possibly I'll do some Wolfram language coding, but let's talk about keyboard for a while. Any new developments in the keyboard space? My Kinesis keyboard is just like yours. It's not tactile, which I don't like. What do you mean? Do you have all the other Kinesis? Yes, the tactile ones. Okay, let me explain. Let me answer. Okay. So Kinesis keyboard you are looking at, fantastic. Okay, you know, look at how I operate. You know, I talked about efficiency. You know, I'm a keyboard nerd. I studied the keyboard layout. Let's go to keyboard block. Okay, so you can see all the things you want to know about keyboard. So here's ergonomic keyboards. So I highly recommend Kinesis. That's what I'm using right now. And also the ultimate hacking keyboard. You can see reviews, my video reviews, and every detail. Okay, so happy hacking keyboard. I also like. It's the best for macro, key macro. If you want the best key macro system, for example, let me show you okay, so ultimate hacking keyboard. So you can see my current configuration for my keyboard macro. This is fantastic. Okay, so this is my keyboard macros. Okay, switch to last window. This is one of the most frequently used commands. Switch to last window. Okay, or you can switch to wait here. Okay, you can switch to previous window, next window. Okay, one key press. Okay, I don't know if can you see it. Okay, wait. You know, one of the annoying thing about Windows is that it doesn't show windows that you've hidden. For example, I want to go to OBS. It doesn't show because I minified it, idiotic. Rather, I prefer if you just cycle through Windows, it just should turn up every window. So you can see, so yeah, I'm checking if I can see myself. You see, just single key press, okay? So anyway, ultimate hacking keyboard is the most powerful and easy to program with a visual, you know, software that allows you, you know, for example, I want to shrink window. I do this often. You see, you know, press one key. Okay, I don't want this. So you know, press one key. You know, and if I'm a browser, you know. Much of macros here is designed for browsers, okay, because browser is what I use the most. Browsers and Emacs. In Emacs, I've got soft flag keys, as you already know. And in browser, and also see how I switch window. There's no key press. See, typically, you know, the typical programmers, you know, they what they do is Alt Tab, okay. Now here's tab. Okay, so here you see this is what people usually do. So for example, I want to switch to Chrome. You know, let's say I want to switch to OBS. Okay, so you do this. Okay, where's OBS? Which one? I overshoot it. Okay, Shift. Wait, actually OBS is this one. Okay, that's idiocy. Okay, you know, so I don't do that. Okay, so first of all, you should turn on Hoover activate window. So why? So I hope you can see it. Yeah, you can see it in my mouse. You see Hoover activate window. You know, I don't have to, because I type so much. I have RSI right now, like over here. Okay, I don't feel so good right now because I type too much. You can imagine. So why should you use mouse hover click? Because you know, it doesn't, you know, even press a single key, that if you have hand pain, RSI, you have hand injury, the idea of pressing a single key that's painful. Okay, you don't want to press any key. The best thing to do is that you just think what you want to do, and you know, things do it themselves. Okay, so hover to activate window is one of the steps. Okay, so in my videos in the past 2-3 years, you'll not see me do Alt Tab. Have you ever seen this? You don't never see it, because it's either hover, or if it's a last window, I just press that key. Okay, because when you switch windows, by statistics, the most of the time what you are doing is switch to the last application. Okay, so that key. Okay, most of the time. So okay, so that's some tips. So if you want to know, so in browser, let's go back to my keyboard. Do I still have it here somewhere? Okay, no. So go to Emacs, press a key again. You see, close the window, go back to Emacs. I want to launch this in browser, so press a key. You see, keyboard block. Then then let me explain Hoover window. Okay, I explained this many times. So here, XR keyboard blog is every aspect you want to know about efficiency in using a computer keyboard, including what's the best keyboard, ergonomic keyboards, or do-it-yourself ergonomic keyboards. There's so many varieties, okay? Or normal keyboards. Normal keyboard, generally, if you do not touch type and this is your thing, okay? Which is fine, okay? Touch typing is kind of, you have to spend a month or two to learn. And it's a good thing, okay? But depending on how, what's your need. If you are a programmer, maybe you don't need to learn touch type. But if you, there are a lot of programmers who says, oh, touch type is not important. Touch type will get you hand pen. That's idiocy. Okay, touch type is very good. But it's true that touch typers will more likely to develop repetitive strain injury. Why? Not because the technique, well, simply because when you actually learned touch type, then you will type a lot more, okay? Like when you code, if you don't know touch type, you have some kind of method of, idiotic, hand and peg, which gets you about 50 words per minute, okay? But once you learn touch type, you will start to write documentations for your programming. You will start to, for example, in my code, everywhere I have documentation, detailed documentation for every command I ever write. Okay, so complete documentation with links and all that. Now, this, if you do not touch type, you will not do this. Okay, you just put a few words. Okay, that's a problem with not knowing touch type. You feel you are doing great, but actually, once you know touch type, you will start to type a lot. So, but if you type a lot, then you'll have higher chances of getting RSI. Okay, so touch typing, that's about touch typing. So let me show you. Yeah, so I have here. So let me show you back. Let's go back to the Hoover. So I have, for example, I have articles on all the things you want to know about typing habit, how do you measure typing speed, how do you learn, and what's the proper, ergonomic sitting posture, and pronation. Is keyboard tenting important, things like that. So here, this section is about typing, and about the Hoover 2-click is over here, okay? So Hoover 2-click, let's see, keyboard shortcut, mouse, Hoover 2-click trackball keyboard shortcut. Okay, it's over here. So, for example, on Windows, you click here is everything you need to know about Windows keyboard shortcuts and whatever software. So, some software I highly recommend is Microsoft Power Toys. Okay, and also AutoHotkey. I have a tutorial here, a detailed tutorial including key syntax, disable keycaps. Many of the frequently needed things, okay, how do you do that in AutoHotkey, and also useful scripts, okay. So anyway, so go back. So that's this is about Windows. Now let me show you about mouse Hoover to activate Windows. So here on this page, I show you how to activate that, okay, on Windows, and also on the Mac. So on the Mac, this is what you want, Hoover mouse auto click. Mac doesn't have Hoover to activate window, but however it has Hoover click, which is similar, but except it will also do a click. It will do a click whenever your mouse stops moving. So on the Mac, I use this, also fantastic. And on Linux, okay, on Linux you also have them, okay. So you have what Linux call it Hoover to raise window, okay. So here's how you set up in depending on which window manager you use. So I have an example for OpenBox, which is LXD, and example for XFCE. You can also do it in GNOME or whatever. Okay, so you have Hoover click, Hoover to raise window, to act, not just to raise window, okay? Not just focus. You want raise, okay? Focus is idiotic. You want to raise the window. And on Linux, you have another thing is hover mouse click. So anyway, go read my articles. I'll tell you the details, okay? So that's here is everything you want to know on Linux about key binding, how to do them, okay? And on the Mac, what tools to use, everything you want to know is here. And of course, emacs, everything you want to know about emacs keys, how to define a key. Let's turn on JavaScript. So we have that. You have key syntax, major mod keys, minor mod keys. How do you change major mod keys, minor mod keys? Everything you need to know, okay, about emacs key binding and how do you define key sequences. So that's about emacs, so let's go back again. You see, previous tab, next tab. That's how I use the browser key macros. So we were talking about there's a question about kinesis, okay? So because I type so much, okay, one of the tip for programmers, if you thinking about, keyboarding issues, what you really want to know is, let's go to typing, okay? So look at the article. Bad keyboard advice from programmers. There's a lot such. What, so, you might wonder, so why do you claim many programmers' advice? You hear them all over the place, on Hacker News, on everywhere. Programmers will tell you, oh, you should do this, you should remap control keys to the cap lock. Idiocy, okay? Extreme idiocy. You should do this or that. The really easy way to the criterion to determine, what type of people gives great advice about keyboard usage is that you want to look for people who type a lot. What does a lot means? For example, novel writers or the data entry clerks. What's a data entry clerk? Their job is to type. Given a data sheet, they just have to input into computer. These days, data entry is less. It becomes extinct because voice recognition takes over in many cases. But still, there are some cases you need data entry. Or in code, for example, stenograph systems. Stenograph, you need to record in real time what people say. Things like that. So I also cover many different systems for input. So there's several stenograph systems. This is a piano-based used in Italy. So stenograph systems, how they work, steno machines, they cost few $1,000s. Okay. So anyway, back to how do you judge what's a good advice? What type of people gives good advice for typing? So you want to listen to people who either they already have hand pen, they went to see a doctor. There are several famous programmers who had that. They went to see a doctor, or people who truly type a lot, like data entry clerks. I was a data entry clerk for 2 years, from 1991 to 1992. 1992 to 1993. Anyway, 2 years, okay? All I do is just typing, keep typing, You sit down on a computer, you just type non-stop for an hour, for the whole day, basically. Of course, you take breaks. So that is, that's a magnitude more typing than programmers, 10 times more, 5 times more. Programmers, they think they know stuff. They tell you, oh, you should do it, key map this way. That bullshit, because when you actually see people who type 10 times more, they got, then they actually have good advice about what's good or what's bad, okay? So that's how you judge. So I have an article on that. Go to typing. So I tell you, some of the idiotic advice from programmers. Programmers tell you should remap control key to the caps lock, which is an idiocy. They tell you should not learn touch type. That's an idiocy because because if you don't touch type, then you cannot even, for a data entry clerk, if you don't touch type, you're out of the job. You don't have a job. It's like saying, for example, sports, okay? Let's say football, American football or soccer, okay? So programmers they are saying, oh, you shouldn't get trained, you shouldn't be a professional athlete, because once you become a professional athlete, you're prone to injury. Yeah, that's true. But that's not because you are professional. That's only because you do a lot more in a more professional manner. It's like kung fu, or karate or self-defense. Those people who actually learn kung fu, they learned, martial arts, or they become champions in, martial arts champions. They are prone to more injury. In fact, almost the professional boxers, they all have injuries. Okay, in many cases, serious brain damage because of the concussion. But that doesn't mean their professional training in boxing is bullshit. Okay, that's very good. It's only because they do it too much. Same thing with typing. You want to learn touch typing because that will make you far more efficient. Given X amount of typing, you will do it more faster and easier on your hands. Okay, less strain on your head, on your shoulders, because you can finish it in 10 minutes. Without touch typing, you will finish it in 1 hour. It's a big difference. Okay, but why is that touch typing people are prone to injury? That's because they type 10 times more. Okay, so that is why, not because the idiotic programmers, they say, oh, you shouldn't learn touch typing because this unpack is fine. And then they cook up reasons. Okay, they will say, oh, for a programmer, you don't need to learn touch type because programming, most of the time you are spent in thinking. It's idiocy. If you don't touch type, then you are not likely to write full documentation, which in turn damages your design flaw. Okay, when you write a function, for example, in my case, my personal style, I almost always write full documentation first before I even code a single line of code, because that way I know exactly what I know what I want. I thought about the problem fully and write it down. When you write something down, it helps your thought flow. Okay, then programmers say, they have many things to say. They say, oh, this keyboard is better than that keyboard is better. That's bullshit. Okay, the typical programmers. Then they say, swap caps lock and control. Then they have reasons, and particularly because the programmers, especially the Unix type, the Linux type, the emacs, the VI, these elite type of hacker type of coders, they'll tell you what to do. They think they are the supreme. They think their advice, their thinking is the best. They say, oh, you should swap caps lock with control key. Oh, you should use Linux. Oh, you should use tidying window managers. These idiots. You don't know what they're talking about, okay, when you go look into detail scientifically. So basically they are saying, you should not learn touch type. The best way to avoid injury is not to go pro. That's what they are saying. And some will say ergonomic keyboard is useless. You can see that on YouTube if you just search for it. They will say ergonomic keyboard is useless, or Vorak is useless. You should just hunt and peck and QWERTY. That's idiocy. So again, you want to listen to people who are qualified. How do you judge? You want to look at those people who really type a lot. What do you mean by a lot? What do you mean by type a lot? Okay, scientifically, that means you measure your number of keystrokes by a key log. Okay, so this article, how many words do you type a day? You actually can measure it. Okay, so for example, look at keylogging software. I have compiled the list of keylogging software. So you can actually see how many number of keystrokes you type a day. You do this for a month, you can average. Then you can see, oh my God, you don't type at all. You fucking idiotic programmers compared to other people. So I have a key log. So here's a key log of my emacs. I logged my keys for about 10 years by now. Beginning like 2008, something like that, when I started to do Ergo Emacs project, which is a Emacs mod. So you see, so measure your number of keystrokes you type a day. So then you know what you're talking about. Okay, so there are some of the things about keyboard, about typing, about stuff. Okay. Now, did I answer the question about kinesis? I think that's it for today. I'm done. Okay, 11 o'clock. We talked for an hour. So about key switches. Okay, so I recommend linear light switch. So for example, Cherry MX red or Cherry MX silent red. So I recommend linear red switches. I mean linear light switches. The switch should not have more activation force more than 45 grams. Okay, that's what I recommend. Now, this is important. I highly recommend this, especially if you already have some kind of typing discomfort, okay, like I do. It makes a big difference, okay? I mean, if you are a beginner, if you never got into ergonomics before, okay, and maybe you are young, you just start out, I recommend, like right now, go out, buy, I mean, if you don't even touch type, okay, if you don't know anything about ergonomic keyboard, I recommend you go out, buy a Chinese cheap mechanical keyboard right now. You want mechanical key switches, absolutely, okay. For example, I have 30 years experience because beginning in 1991. In 1991, that's before the internet, I read a lot about typing. I'm kind of a typing freak. So I started to touch type in 1988 on a typewriter, okay, on an electric typewriter. I learned QWERTY touch typing in 1988. Then in 1994, so 6 years after I touched type for 6 years on QWERTY, I switched to Vorak. I learned about Vorak in 1991. So I went to the libraries, read about research on typing and different layouts. So anyway, so I read a lot about about keyboard, about typing, about layout, all kind of things since 1990s. Okay. And I switched to Vorak in 1994, and the first time I used Emacs is 1998. Okay, so that's my basic history. You can find the article. I have several articles about it in detail about my RSI history. Just search for Sali. Okay, so Sali RSI history. Okay, so you'll see it. Sali RSI history. So somewhere here. Okay, so it's not finding the right article. Sali typing history. Anyway, it's linked somewhere. You'll find it. Okay, so basically, anyway. So what I was going to say. So yeah, I recommend red linear switches. If you already have RSI, very important. And brown switch is not good, okay? About 8 years ago, when I started to got into, all these ergonomic keyboards, because actually it began in 2006. Anyway, so in the beginning, I don't care about, when you look at on Reddit, the mechanical keyboard communities, you will see these people, they are very particular about key switches. There are so many types. Okay, so let's show you. Okay, so keyboard design, key switches. Okay, so here you're looking at, here's the most common rubber dome switch. This is the switch on your keyboard, which is no good. And here's a scissor switch on your laptop. It's also rubber dome, no good. Then you have mechanical switches. The most popular is Cherry MX, looks like that. Okay, so all my keyboard you see it's all mechanical switch. Okay, so this is Cherry MX red silent. Okay, and this one is this one is also red silent, but it's made from China. It's what's the name? I have Kyle. Okay, this is a Kyle red. So Kyle red is actually 5 grams heavier than Cherry MX red. I want light as light as possible. So anyway, so I was saying, many years ago, 10 years ago, when I started to get into mechanical keyboard, I look at all the people, they talk about that. I think, I thought that these people are crazy. These people are nut jobs. Doesn't matter, okay? Doesn't fucking matter. Well, these are, it's the same. Okay, just get one, just get one of them. And because consider vast majority of people, 99% of keyboard users, they are using rubber dome, which is far worse. So once you switch to mechanical, that's good enough. Okay, don't be so picky. It's not like, oh, I must have this one. They get so crazy about switches and variations. They talk about that all day and night. I thought these people are nut jobs. So I think, any of them, one of them is good enough, okay? But actually, now I have so much RSI, I type so much. Actually, I have opinions as well, and a strong opinion. I recommend, okay, here's a assumption. If you already have hand pen, okay, if you already have RSI, or if you truly type a lot, okay, then I highly recommend you want to get red switches. You don't want the brown, okay? You don't want the brown. You want the red switches, okay? That's a recommendation I can give you. Also, if you just start out, you don't know nothing about it. Right now, right now, go to my website, go to this page and get a Chinese cheapo, $40 right away, okay? Do it. Just Chinese cheap ones, $40. They work fine, okay? They'll last you for a year or two. Important if you type a lot. Okay, that's it for today. I talked about an hour. That's it for today. Let's quickly read some comments. Okay, donate to me, okay? Donate. Go to my Patreon. You'll see my links on my Patreon. Okay, Patreon me, Amazon gift card me, pay me if you like my stuff. Wolfram language you can download. So we talked about Wolfram language. Go to my homepage, xali.info. Wolfram language you can download for free, and you can watch my past videos on it, details about the language. So here's a question. How do you define a limit to prevent the geometric inversion from running forever? That doesn't run forever. It's just a function. It's just a function that takes a point and returns a point. Okay, so it's not a recursion thing. So it doesn't run, there's no such issue. But of course, you can repeatedly apply it. You can repeatedly apply the inversion. But if you repeat it, it just reverted back to self, because it simply swaps points outside the circle to inside. If you repeat to the same points, the function, inverse function is itself. So that's what the way to say it. Happy hacking keyboard, okay. FS straight. So do I think keycaps are important? Keycaps are not really important. You know, keycaps is you know, it's good for, it's not really important. Okay, keycaps. So if you go to, so you can see all the details about keycaps. Keycaps, you know, basically they are for looks. You know, for example, there's, you know, different technologies for keycaps. Mostly the plastic material used to create a keycap. But the most popular is ABS plastic. ABS is some kind of chemistry. Okay, so you know, so if you have a cheap Microsoft or Logitech keyboard, that's what you have, ABS keycaps, and you have this shine problem, or you have this kind of problem. You see, they rub out. So the better quality is PBT keycaps, which is more expensive. So then you have also key label technology. So if you have a cheap keyboard, chances are Microsoft and Logitech, cheap ones, non-gaming ones, you have this kind of label technology. They rub out, you know, after a few months, after a year. So there are many technologies for key label. So for example, here's a laser etched one. Then you also, you know, quite a few. Then you have dye sublimation, which is the best. Okay, so here is a picture of dye sublimation technology. So essentially they, you know, the key label is part of the plastic, you know, so it will never rub out. So of course they are much more expensive. And by the way, you can buy keycaps on Amazon. And then there's also print in front, which is great because you never touch the key label, so they don't rub out. So this is also a great thing. But also keycaps, you know, they are pretty keycaps. For example, cute keycaps you can buy, but they are just for the looks. So I've been using, Celtic Orthodox says, I've been using the same 2 GB netbook for 7 years. No external keyboard. I work on it for hours a day. Okay, I guess you are good. You know, you know, the typing injury happens. It depends on people. You know, for example, it also, okay, so you saying you've been using this laptop for 7 years, typing for hours a day, but exactly how much you type, like I said before, key log, you know, tell me exactly how many keystrokes you type a day. You might be surprised. You don't type. So in your case, you don't actually type. That's why you don't have a problem compared to other people. So that's it for today. Thank you guys for watching. Bye. Okay, so go back to Wolfram language. Go back to